Hello, I'm Philip Stoten. I'm here on the Scoop Studio at SMT Nuremberg, and I'm joined by Karthik from India. Great to see you again. Thanks for stopping by. In Europe, automotive is the dominant industry. It's certainly the industry that drives us hardest in terms of technology. What are they asking you for at the moment? What are the big trends in that sector?
I'd say, it's a great time to be in automotive because before getting into products, I'll talk about the drivers. So we're seeing more electrification within the petrol or the benzene car. So when I say electrification, don't think of hybrids or electric vehicles, just the transition from 12 volt systems to 48 volt systems. Huge driver, because that means more power. And that puts constraints, which obviously is an opportunity. Along the lines of more electrification, you got hybrids, plug-in hybrids, and fully electric vehicles. So again, huge growth driver. Then you've got ADAS, Advanced Driver Assist Systems, where you've got sensors which are going to be mandated by law, and you're already seeing a lot of them today. Your lane change sensors, your pressure sensors. So you got sensors up the wazoo. Then you've got your V2X, which is the vehicle being your central node, but communicating with other vehicles, again from a safety standpoint to avoid collisions, with infrastructure, your cell phone, and then vehicle to everything. So that's a big deal. And then finally, the move towards autonomous vehicles. So with all these drivers, the status quo is no longer the status quo. And like I said, that brings more opportunities, primarily in terms of power and therefore increased reliability conditions. And now drilling it down to a soldering standpoint, you've got alloys where you need alloys that are probably stronger and more reliable than SAC 305, as well as flux technologies. So when we talk about more electrification, that basically means the big guys like Ford, BMW, and then down the supply chain like Conti, Bosch, Visteon are saying, from a flux from a flux standpoint, standard surface insulation resistance rules and the standardized tests are no longer applicable. So to give you an example, what they're saying is if the minimum threshold is 100 megohms, they're saying we want to go up to 5,000 megohms. That's a big deal. Going from 0.5 millimeter pitch to 0.2 millimeter pitch, going from 168 hours to 1,000 hours. So, unless you're not ahead of the curve in terms of engineering your flux to pass these check boxes, it's game over. Because these drivers, it's not something they're looking at 5 years from today. It's happening today. Likewise, alloy, your operating temperatures are going up from 125 to 150 and beyond. And that means SAC 305, which is a standard lead-free alloy of choice, is not making the cut. So you need alloys that are going to check the box with higher fatigue resistance. And that's where we got some of our alloy technologies, which are neither too brittle nor too hard, and therefore are able to withstand higher operating temperatures and the higher CT mismatches. So all of this is what I've talked about is in PCB assembly. So the parallel in automotive for power is high power modules, your IGBT power modules, where again some of the same constraints and the same drivers apply. So therefore you've got opportunities in high reliability alloys, as well as, and that's where our Inform technology fits in, where it's fluxless soldering increases the reliability by a factor of 2 to 3x, but making sure that you've got good bond line control with the lowest cost of ownership. And swinging back to PCB assembly, another driver is low voiding, because voiding is important in terms of thermal transfer, but there's a lot of linkage being made to mechanical reliability with good reason. But when it's applied across the board, now it's a challenge as well as an opportunity. So in some cases, it's dealt with on a case-by-case platform as to what the influence on voiding is with mechanical reliability. In certain other options, certain other situations, you don't have a choice. So you need voiding under 5%. And there, it's a combination of both the flux technology as well as process tools such as reflow profiles, equipment like vacuum soldering, and so on and so forth.
Yeah, and it's being able to measure it and it's being able to have that data. When you're working in the automotive industry with all this complex technology, where it's an interesting supply chain. You've got the car makers obviously at the top. You've got a whole bunch of companies like Continental, Delphi, all those guys at that kind of tier one level. But you're seeing more and more involvement from some of the big EMS companies, the Jabills, the Flexes of the world. Do you work with all of those, or do you come in through a particular part of the supply chain? Who's making the decisions?
Well, the first part of the question, I think we work with all of them. And in Europe, the EMSs have to be automotive centric because it's just too big a business for them to not be a part of. In terms of who makes the decisions, I think that's more supply chain dependent and where they're located, because the Contis, the Delphis are the biggies, and they are obviously been in this game a lot longer. But there's a lot of the sub-module business which companies like Flex and Jabil are very, very capable of, and they're doing today. And because of our historic relationships with them as well as the Contis and the Delphis, we are pretty well positioned to work with the entire spectrum in the supply chain.
Yeah, and it's an important collaboration, isn't it, to work with them to understand what they need and to drive that up and down that supply chain.
Right.
Karthik, thanks for stopping by. Always a pleasure to chat, and good luck with the rest of the show. Thank you so much.
Thanks, Phil.